Now, welcome back, guys. Okay, welcome back. Okay, welcome back. We're gonna actually do the to continue our discussions over the questions. Okay. Now, here, okay, so we actually know the name of synthetic polymers that actually have the same linkage as the protein. That would actually be the nylon. Okay. Oh, you can actually use Kevlar. Okay. Kevlar is one of the synthetic material that we use with amide linkage anyway. Now, our proteins are hydrolyzed to give a mixture of colorless amino acid. Now, describe with the aid of the label diagram how paper chromatography can actually be used, okay, to actually identify, okay, amino acid presence in the mixture of amino acid present in a mixture of amino acids. Okay. Now, for this one, okay, you have to actually make sure that you actually draw, okay, because of course, we're gonna actually need to draw, okay, how paper chromatography actually looks like. Then after that, okay, how do we actually compare? Now, it started with actually using kamu punya particular beaker, okay. So you're gonna actually do a beaker, okay. Then after you actually draw the beaker, okay, you're gonna actually draw your particular paper, okay. Now, once you actually draw the paper, okay, make sure that you actually have something to hang it on, okay. So it's something like that, okay, and make sure that you actually have lid, okay. So I'm gonna actually put some sort of like lid here, okay. Then I'll take my particular pencil, okay. So you have to use, oh sorry, you have to use pencil to draw the benchmark, okay, or the starting line, okay. So I'm gonna actually use a black line, okay. So I have to use particularly here, okay. So after that, you're gonna actually have your particular sample, okay. Now you actually have your sample, okay. So sample here, okay. Oops, okay, I should actually use a different color. So I'm gonna actually use purple color, okay. So put a sample on that, okay. Now after that, okay, you have to actually submerge the, put in the liquid, okay, or you need to submerge it with then, okay, a solvent, and make sure that the particular, I should use a different color. I should use a blue, okay. Oh, this color is fine, okay. So we're gonna actually use that, okay. And the liquid should not actually touch your sample anyway, okay. So it allows this to actually move, okay, to different directions, so moving upward, okay. So that would actually move upward, okay. Then after that, once you actually have your particular completed the chromatography, okay, so they're gonna actually show different spots, okay. So I'm gonna actually have sort of like, the paper. Oops, different color, okay. Oops, okay. So we're gonna actually have that, okay. So it's a different color. Then you have that particular line there, okay. Now the spots now is actually disappearing, so you should actually have a different colors, like here, then here, then here, okay. Then you compare that with your particular sample, okay. So each of that, so that's how you do a paper chromatography. Any questions? No question, guys?
No.
No, Putna? Ada, what's the question? You can ask through the mic. Okay, if you want to draw the color, yes, what happened? The color, means a different color. Not really. You have to actually show different particular positions, Saja. Because in this case, you are not actually allowed, you're not allowed to have a color pencil anyway, okay? So basically, in terms of that, you can just actually show a different particular, patterns at the position of the spots. That's fine, Okay, then after that we compare the positions of the spots. That's actually one of the way, but most of the time I tell you what, okay, it is actually colorless amino acids. Okay, it gave a colorless amino acid, so in this case there should not actually have a color. Okay, what happened is that after you actually finish the chromatography, okay, you have to spray them with locating agent. Okay, so basically you definitely gonna okay, use a locating agent. So the final steps after, okay, you actually have done the chromatography, please do remember to spray it with locating agent. Then the locating agent will actually show the different color. So far so good?
Yes.
So remember that, because it actually mentioned that a mixture of colorless amino acids. So it has to be with the locating agent. So once you complete it, okay, so let it dry. Then after that, take your locating agent and just spray it, and it will show you color. Okay. Now you compare the positions with your samples. Okay. So is it good? Okay. Now let's go to the next question. So here, carbohydrate can actually be hydrolyzed. Name the classes of compound formed when actually carbohydrate are hydrolyzed. So basically, in terms of this, what was actually ano? It is more classes, okay? Monosaccharides, okay? Or simple sugar, okay? So it's actually we want a class, okay? So what's the family of that? So sugar, okay, it's monosugar, disugar, okay, and also polysugar. Okay, so monosaccharides, disaccharides, and polysaccharides. So polysaccharides hydrolyze to actually form monosaccharides. Okay, so for so good.
Yes.
Now let's actually talk about this. Another one is actually, you can see here is ester. Okay, ester linkage. Okay, this ester linkage. Okay, so why we actually call it ester linkage is because of the ester formations. Okay, it is actually a reaction between alcohol and also your particular carboxylic acid. So when the two react, they're gonna actually form ester. Now ester is actually sweet smelling substance. Okay, so this is actually what gave you characteristic of the smell. Like for example, if you burn your kambing, okay, or the lamb, you can actually smell it. It's because of this. Okay, now this fat is polyunsaturated. Okay, so what we mean by polyunsaturated, so okay, I know, okay, I'm hungry. I haven't actually had my lunch yet. So I was too busy, okay, with classes. Now, polyunsaturated, okay. Unsaturated means that, okay, they're gonna actually be double bond. Okay, remember that the term, okay, polyunsaturated. So unsaturated means that there is lots of actually, I mean, they're gonna be C double bond C. Okay, so in this case, kalau polyunsaturated artinya banyak C double bond C. Okay, so feel so good?
Yes.
Okay, now let's clear that off. Let's move on. Okay, so what else? Okay, describe a chemical test. Okay, use the presence of unsaturated fat. Okay, fat, okay, to show that the fat is unsaturated. So basically you use, okay, what is the reagent that kita ni pakai untuk actually apa, to show that there is actually unsaturated. Okay, so C double bond, the presence of C double bond C, that would be bromine water. Okay, so it's good. So that is actually bromine water. Okay, so it actually be bromine water. So testnya, it will decolorize. Okay, decolorize. Okay, so it's good. Now name a synthetic macromolecules that contain stem linkage as kamu punya particular. Okay, what is that? Fats. So fat is ester. So you're gonna actually use polyester. Okay, polyester is one of them. Okay, you can actually trirene. Okay, that would actually be two things that you can actually mention, but I will go for polyester anyway, okay, because it is an ester, banyak ester nikah, so I'll go for polyester. Okay, so it's good.
Yes.
Now let's clear that off and move on. Okay, so here, okay, we're gonna actually look at, okay, now only liquids that contains moving ions can actually be electrolyzed. Yes, because only moving ions can conduct electricity. Remember that these liquids are called the electrolytes. Okay, now complete the following table shows the products formed when actually some liquids are actually electrolyzed using inert graphite electrodes. Okay, aqueous copper to sulfate. So remember, okay, the positive electrode actually attracts the negative. So this positive electrode is the anode, okay? So this is anode, okay? And the negative electrode is actually attracting positive ion. So that's actually cathode, okay? Now, okay, remember, okay, this charge of an ion, okay, depended on the concentration, okay, and okay, the charge of a cation depended on your particular reactivity series. Okay, so if we're talking about an ion, then we look at the concentration, the least, okay, sorry, the more concentrated, okay, or the concentrated, okay, anion will be discharged first. So in this case, okay, we actually have four. I mean, two of them are actually your particular anion. So anion that I will actually definitely gonna remove would actually be, in this case, is hydroxide. So if you're removing hydroxide, you will actually form oxygen. Okay, so the answer for this would actually be oxygen. Okay, so here, okay, would be oxygen. Now the cathode, okay, the cation dependent on the reactivity series, the least reactive would actually be removed first, antara hydrogen and copper. Copper would actually be the least reactive. Okay, so copper will be discharged first. So here, okay, you can actually produce Cu. Okay, now, okay, same like actually what happened is that molten lead to Br. Okay, so in this case, there's no other choice. Okay, so that's the only anion and cation. Then the only thing that you will actually be able to remove. Okay, so in this case, okay, the anode would actually be R2. Okay, then your particular cathode with be lead or Pb. Okay, so if it's a good.
Yes. So yang biora tu bromine gas kah?
Br2 bromine gas, yes.
Okay.
So it's a diatomic. Remember, it's actually a diatomic. Mostly, it's actually a gas. Okay.
Okay.
Good. Okay, now let's see. Okay, next one. Okay, let's clear that off and move on. Okay, so B. Okay. So in this case, when concentrated aqueous sodium chloride is electrolyzed, chlorine is formed at the positive electrode. Okay. Then after that, the hydrogen and negative electrode, which is the cathode. Construct the ionic equation to show the formations of chlorine at the positive electrode. Now the chlorine, we always start with actually ions. So we want a chlorine or chloride ion. So Cl minus, okay. Then, okay, remember in this case, I'm gonna actually use minus because it's actually start with minus, okay. So you actually have electron, okay. Then you will actually have your particular, okay. Cl2, okay. Cl2, okay. But remember, when it comes to actually this, okay, I'm gonna actually need to move the electron to the other side, okay. So it would actually becomes like this, Cl, okay, minus, okay. Then you will actually have that, okay, Cl2, okay, plus E minus, okay. Now, here you have to balance it off. Okay, so you're gonna actually, since Cl2 require 2Cl, so you have to put 2Cl here, okay, and also the two particular electrons, okay. So if it's a good.
Yeah.
Okay, that's good. Okay, now let's see. Explain why hydrogen is formed at the negative electron rather than actually sodium. Okay, okay. Hydrogen, because, okay, hydrogen is the least reactive. Okay, so is it good?
Yes.
So it's least reactive. Now, name a metal manufactured by electrolysis of a molten ionic compound. That would actually be aluminium. Okay, so is it good?
Yes.
Because extractions of metal under dua saja, we actually have extractions of iron, which is by blast furnace, and the other one would actually be electrolysis, which is actually your particular aluminium. Okay. Now, any questions so far?
No.
No. Okay, let's move on. Okay, let's move on. Okay, next questions. Okay, hematite. So this is iron ore. Okay, heme. Okay, so there's actually iron. Okay, iron ore, limestone, and coke are actually heated together in a blast furnace. So now we actually talk about extractions of your particular iron. Okay, in the manufacturers of iron. Okay, state why each of the following compounds are needed in the blast furnace. Hematite, of course, it contains iron. Okay, it is an iron, so basically it is actually contain iron. It's an iron ore, it contains iron. Limestone, why it's actually limestone actually needed? Limestone needed in terms of to purify, okay, to remove the sand. Okay, so to purify that particular kamu punya iron ore. Okay, iron ore, iron kamu. Okay, then you actually have your coke. Okay, coke is carbon. Okay, so this is to generate carbon monoxide. So it actually be able to reduce, okay, your particular iron oxide to become iron. So far so good?
Yes.
Okay. Now, here, iron has a high melting point because it actually has a strong metallic bond described using a level diagram, metallic bonding. So we already talked about this. So make sure that you actually know metallic bonding is actually where everything is actually plus, 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 okay? Arranged in the same, in regular manner and surrounded by sea of electrons, okay? So you definitely need to remember that. So, you know, okay, because it is important, okay? So you're gonna actually have positive, okay, positive, positive, okay, positive, positive. You have to explain that, okay? So it has to actually be, okay, kamu punya cations, central cations, okay, surrounded by your sea of electrons, okay? So that's actually how it works with your particular, okay, what you call that, okay, metallic bonding, okay. Now, any questions for that?
No.
No. Clear. Okay, now let's move on to the next one. When iron is made into an alloy steel. Now, what is alloy? A mixture of metals. So why do we need to actually have a mixture? So to make it actually hard, okay, and you know, okay, more sustainable to actually other things, okay. So in this case, okay, alloy actually does not actually have the same characteristic of a pure metal because pure metal is actually ductile, millable, okay, Paris, you know, it easily cut, okay. For your iron, sorry, for your alloy, no, sorry, okay, it's not, okay, it's a mixture. So they don't actually have that particular, what you call that? The atoms, when you mix them together, okay, the atoms are not the same size. So they do not actually occupy the same planar, okay, so they're not unable to slide past each other, okay, so they're unable to slide past each other. So that's one of the reason why it's really hard you know, to actually shape it, to actually pull it and all that, okay. Now, high carbon steel are stronger than iron but are brittle, okay. So the properties of low carbon steel, okay. So what we mean by that, okay, you know, okay, dia cakap actually iron but are brittle. Okay, so basically state a property of low carbon steel. Okay, so low carbon steel, that would actually be, you know, it's malleable. Okay, it would actually be softer. Okay, so these are the reason why there's actually, you know, a difference in terms of kamu punya particular composition. Okay, it affects that particular physical properties. Okay. Now, when magnesium powder is added to aqueous iron 2 sulfate, the following reaction occur. MgF2 plus plus and Mg2 plus and Fe. Okay, now explain using electron transfer why iron 3, okay, sorry, iron 2 are reduced, okay, in this reaction. So you actually have to mention about the transfer of electrons. So meaning to say you have to actually talk about gaining or losing of electron. So you actually, in terms of that, iron 2 are reduced. So you can actually see, okay, the sini, okay, the iron, okay, to gain electrons, okay. So they gain electrons, 2 electrons to actually form Fe. So if it's good.
Yes.
Okay, can I use oxygen? We can't. Can I use oxidation state? We can't. Okay, because that particular question specify then 1 electron, so you have to mention whether you gain or actually you lose. Okay, so in this case you started with 2 plus, now you becomes 0. So artinya to cancel off that particular 2 plus, you need to gain minus, okay, or electrons. Okay, so there are 2 electrons that you need to gain because 1 electron contribute to 1 minus. Okay, so if you have 2 electrons, then you're actually gonna go gain 2 electrons, then you cancel off with that particular Fe2 plus. So is it good? And now you see
Yes.
that actually what would you observe? Now observation I've told you before, okay, you need to look at this product, okay, punya state, okay, you actually have AQ, okay, you actually have your particular solid, so precipitation should actually be apa tak? Observe, okay, so it's good.
Explain lagi, Sir.
This one, okay, you actually be able to see magnesium 2 plus, jadi Fe kan tu solid, okay. So Fe, okay. So in this case, okay, there's a precipitation, okay, actually is going on, okay. So it's good because ada solid tato. But again, this is
Okay.
actually the solid, okay. So again, in this case, magnesium powder is added to aqueous. So the following reaction actually occur. So you're gonna actually have a solid, okay. So again, it start with actually or changes of color, okay, from green, okay, which is Fe2 plus, okay, become pale, okay. So it's actually fading. So and precipitate actually, you know, um apa tu namanya, form, okay, because of the Fe, okay, solid. So it's a brownish, you know, greenish brownish punya particular solid, okay. So feels good.
Yes.
Okay, now let's see, move on, okay. So here, okay, the flow chart shows the reactions of metal. This is actually really easy, okay. Metal A, HCl, metal plus acid will always give you hydrogen gas, okay. So it's going to be H2 here, okay. So definitely it's going to actually be H2 because metal plus HCl. So metal plus HCl, okay, give you green solution. So basically green solution. So you need to know that green is actually iron, okay. So we need to know that green, kalau yung biru, okay, or blue, then it's actually copper. But this one is actually green. So I suspect it's gonna actually be, you know, okay, chlorine for no iron, okay. So it's good, okay. So here, okay, you have, if I actually have the green, so green actually start with iron, so I'll just put actually iron here, okay. So Fe, okay. Now if Fe react with this, okay, then you will actually have chloride because, okay, chloride salt will actually be formed. Why? Because you use hydrochloric acid. So Fe, okay, Cl2, okay. Okay, so is it good?
Yes.
Okay, now let's see in terms of data, in terms of data, okay. In terms of this, okay, you look at that. FeCl2 access NaOH, then it becomes green precipitate, okay? So that would actually be an exchange, okay? So you use NaOH. So artinya, this would actually be, instead of Cl2, it changes to FeOH. Salah. Okay. Oh, so was it good?
ER.
Okay, now when you actually have FeCl2, okay, then you actually, what's that? Cl, okay, then yellow solution, okay. So in terms of that, okay, it's the same, okay, FeCl2. So a Cl2 is actually what you call that, a reducing agent. So this would actually become, since it's actually green to yellow, it's become darker, okay, so it becomes darker, so it should be, okay, FeCl3. So ya apa kenapa sebut bracket atau, okay, Cl3, okay. So because now the Fe changes from Fe2 become Fe3. So it's good.
Yes.
Okay, now from this, and of course red brown precipitate. So again, this would actually be, you just need to change since you actually reacting it with NaOH. So Fe, okay, jadi instead of Cl it becomes OH. So here is FeOH3. Okay, so it's good.
Yes.
Okay, Ifa, okay, Ifa.
Yes.
Okay, now this is actually really important, because kenapa tadi why we actually change it Fe jadi Fe2 plus jadi Fe3 plus is because of this particular Cl2. Okay, it is actually, you know, okay, it helps them to actually becomes oxidized. Okay, Fe2 plus jadi Fe3 plus. Okay, so far so good.
Yes.
Okay, now, okay, so let's actually clear that off. Okay, so we know sudah apa jawapannya for the others. Okay, EF, so you found out everything, so it's actually just worth 6 marks. Now let's move on to actually kamu punya this. Okay, B7. Okay, so alkane. Okay, so basically this is actually the least reactive among other carbon, homologous series of the hydrocarbon. So there are 2 alkanes in the molecular formula C4H10. Draw the structure, show all the atoms and actually of these 2 alkanes. Okay, so they have a macromolecule, a molecular formula of C4H10. So you have to actually have what we call the isomers. Okay, isomer is actually different structure but sama molecular formula. This is actually kind of easy. First thing first, you're gonna actually write the normal 4. Okay, 1, 2, 3, 4. Okay, I'm not gonna actually draw the hydrogen, so you should know actually how to draw that. Okay, now the second thing, I just need to actually make sure that the number of carbon and the number of hydrogen would be the same. So what I'm going to do, I'm going to actually rearrange the number of carbon or the carbon itself. So I'm going to actually put C, C, and C. Okay, then now I put another C here, so I have C4. Okay, so the number of hydrogen should actually be the same. Okay, so far so good.
Yes.
So this is what we call isomer, okay? Because the same molecular formula, but different molecular structure. So far so good?
Yes.
Yes.
Okay. Now, they have different physical properties anyway. So this would actually be, I'm gonna actually put is A and B, okay? So A and B. So B is more rounded shape, okay? So they would actually have low MTBP compared to actually the one yang flattened, okay? So reason kenapa, the flattened one, they actually have high contact point, okay, so they can actually have more van der Waals interactions or intermolecular forces compared to kamu particular spherical shape. So they actually have less contact point, so they would actually have less intermolecular forces. So MPBP would actually be higher in B, in A, lower in actually B. Okay, so that's good.
Yes.
Now let's move on. Okay, so one of the actually alkane in the molecular formula is actually a butane. Okay, butane is actually used as fuel. Now complete combustion, remember the complete combustion, they would actually form CO2 and H2O. So you have to balance that off. Okay, so you actually have C4H10. Okay, C4, okay, C4H10, okay, plus O2, okay, will give me, okay, CO2, okay, CO2, CO2 dengan H2O, H2O. Now, here it's easy to balance it off, okay? So you're gonna actually just look at the number of carbon. So carbon is 4, so I'm just gonna actually put carbon dioxide 4, okay? Then look at hydrogen, hydrogen is 10, so there's only 2 here, so it's actually, I put it 5, okay? So now what actually left with is actually, I need to find the number of oxygen in this product side. So 10 campur 8, okay, 8, okay, 5 campur 8, ya, 4 kali 2, 8, okay, campur dengan actually 5, okay, 8, 9, 10, 11, 12, 13, so 13. So in here, I'm just gonna actually put 13 over 2, okay. So is it good? Now you can only use fraction, okay, for diatomic molecules. Remember that. Only use fractions for diatomic molecules. So because the 2 would actually cancel off with that. So you have 13 oxygen anyway. Okay, so is it good?
Yes.
Okay.
Yes.
Now, describe one problem associated with incomplete combustion. Incomplete combustion, we're gonna actually have 2 things, okay? One, toxic gas, which is carbon monoxide, and second is actually smoke, okay, which is actually the soot, okay, that comes off from that particular exhaust pipe. So far, so good?
Yes.
Now, carbon monoxide, remember, it binds permanently with your hemoglobin. So, okay, it would actually be difficult for you to breathe, okay? And eventually, if it's too much poisoning of carbon monoxide, they're gonna actually die anyway, okay? Now, butane react with the chlorine in the presence of UV light, okay? Write the equations for this actually reaction. So basically, substitution reaction. So you just need to substitute only. So here, okay, remember that you actually have, okay, C butane, so C4H10, okay, C4, okay, H10, okay, plus Cl2, okay. So you're gonna actually have, okay, oh, what's that? Okay, Cl2, okay. So you're gonna actually have, okay, you can actually put, okay, C4H9Cl, C4, okay, H9Cl dengan HCl. That can actually be done, okay? So again, you have to make sure that you put the conditions on top of here, okay? So UV, okay? So UV, okay? So if it's good?
Yes.
So why I do that is because of, I don't want to balance it off so easily. I just can actually just change it anyway, okay? You can actually put, you know, change the whole thing becomes CL pun boleh. It's up to you guys anyway, okay? So it's good.
Yes, sir.
Now let's move on, okay? We actually have 6 minutes, okay? Now, nonane, okay? C9H20 is heated strongly in the presence of catalyst to produce 2 made, okay, with alkane and alkene. So this type of reaction is cracking, okay? So it's actually a longer, okay, kamu punya hydrocarbon now made into 2 different, not 2 particular products, which are the alkane and alkenes. So in this case, it's actually going to be your particular cracking, okay? So cracking itself. Now, alkane G contain 84% of the mass, carbon or by mass. Calculate the molecular formula of actually this, okay? So basically you have to make sure, okay, that you will actually have carbon and hydrogen. So to find the hydrogen is 100 minus 84. Okay, so hydrogen is, okay, carbon, okay, and hydrogen, okay, so here, okay, then carbon is 84, then your particular hydrogen is what? Okay, hydrogen is 84, 100 minus 84, that would be 16, okay. Now, from there, you actually have to, okay, divide everything by, okay, it's kamu punya particular AR 12, okay, then 16 by 1, okay. So here, you're gonna actually have your particular 84 divided by 12. 84 divided by 12 is 7. Okay. Then 260. Okay. Now, do I need to actually continue with the, divided by lowest mole? No, that is empirical formula. We want a molecular formula. So molecular formula, you stop until you actually divide that particular number with the AR to find the mole saja. So that would actually things yang you have to remember. So in this case, the molecular formula is C7, okay, H16. So was it good?
Yes.
Okay.
Yes.
Now the formula of H, this is easy. Okay, the formula of H, you're gonna actually you started with actually C9, okay, H20, okay. Now you crack them off to form one of them, which is C7, H16. So what's left is C, okay, 9 minus 7 is actually berapa tau? 2, kan? C2, H, okay? 20 minus 16, 4. That's it, okay? So it's good?
Yes.
Yes.
Okay, that's good. Okay, let's move on. Let's clear that off, okay? Now, here, sama jua, okay, construct the equations, okay, to show the directions of butane 1-ol with potassium. So again, apa ni? Construct equation to show the reaction between butane 1-ol, okay, with potassium, okay. It's the same, okay, but you need to change that particular Na to become K. So is it good?
Yes.
Okay, describe chemical test for hydrogen. So you're gonna actually use burning splint. Okay, it's a chemical test. Okay, so it is actually, yeah, burning splint. Okay, using burning splint and a pop sound. Okay, so is it good?
Yes.
Okay, now a sample of containing unknown group 1 is added to excess ethanol. The volume of hydrogen gas formed, okay, in terms of temperature, room temperature and pressure is a name, okay. Calculate the relative AR of the group 1 element and suggest the identity of this, okay. So, and of course, in this case, you're going to actually you need to find the modulo, okay. So you actually find the mole of hydrogen gas because this is room temperature and pressure. So 400, okay, divide by 1000, change it to dm3, then divide by actually 24. Then lepas itu, you find kamu punya particular mole of, what's that, okay? It cakap unknown, okay, sample, okay? So it would actually be unknown sample group 1. So it would be, okay, X2 is to 1, okay? So the particular equation would be, mole ratio is 2 is to 1. 2X is equal to 1 H2. So in this case, okay, find that particular mole using mole ratio. So again, I'm going to actually 400, I change that to dm cubed first, divide by 1000, then divide by 24, okay, 0.01666, okay. Then after that, I use mole ratio, so 1 is to 2. Now, this is actually the one I found, that the mole of hydrogen. So mole of that particular group 1 would actually be the same as Na, which is 2. So I times that by 2. So the mole is 0.333, okay. Then lepas itu, what actually happened, okay? So you have 0.33333 mole, okay? Now I want to actually find ia punya particular AR. So mole is equal to mass over AR. So I want to find AR. So mass divided by mole. So mass is 0.233 divided by the mole today is about 6.99, so 7. So it's around 7. Okay, now I hope that you actually understand that, because we actually comes to our end of the sessions. Okay, we might actually do it tomorrow again. Okay, so if we have time. Okay, so that's it for today. Thank you very much for your time.
Thank you, sir.
Thank you, sir.
Bye.
Bye.
Bye.